present here. Welcome to the Asteroid Day lecture, public lecture happening today at JNP. Asteroid Day is usually celebrated on the June 30th, but tomorrow being a planetarium holiday, we are having the Asteroid Day lecture today. And I welcome one and all, and also people who have joined us live on YouTube. And as you can see, the title of the talk is Survival at Stake, Defending the Earth from Asteroid Attack. And today's speaker will be Dr. B.R. Guruprasad, Director of JNP. People may have attended his talks here at JNP before, but I'm anyway going to introduce the speaker of today. And Dr. B.R. Guruprasad is the director of this planetarium. Before this, he has served as a satellite scientist in ISRO in the field of satellite mission planning. And later, he headed the media and public relations wing of ISRO. Apart from all this, for more than 2 decades, he has been very active in science communication. He's very passionate about science communication, and he has authored 13 books, among which some have been translated to various Indian languages. He has published science articles in reputed newspapers and magazines in both English and Kannada languages. And he has also been involved in teacher training programs, science quizzes, conducting workshops for students from various parts of the country. I heartily welcome Sir to this program, and I request him to start the lecture. Once again, welcome to all of you.
Hello. Yeah. So, good afternoon to all who have come here for this lecture, Asteroid Day lecture, as well as those of you who have joined through YouTube link. Okay. Today's lecture is related to the Asteroid Day, which is I don't know whether not celebrated, it is observed on June 30th of every year, and as per United Nations, because and in 1998, okay, on June 30th, an asteroid, you may call it, I don't know whether you call it as asteroid or a piece of asteroid called meteorite. It came and at a tremendous speed of more than 50,000 kilometers per hour, and it did not reach the earth. Of course, it exploded in the air, and it was a disaster. Fortunately, the event happened over a place called Siberia. All of you know that it's a very isolated place. But anyway, about 80 million trees were destroyed, in fact. 80 million is 8 crores. So nearly 1,200 or 1,300, some people say 2,000 square kilometer area of forest, totally 80 million trees. If the same thing were to happen over some city, then I'm sure that city would have had it. It would have been destroyed, okay, or it would have been disastrous for the city. Anyway, to create awareness about the asteroids and the threat some of them pose, not all of them, threat, some small number of them pose to Earth, to create awareness on that. So United Nations now, all over the world, there is awareness that it should be observed as World Asteroid Day. Actually, it is June 30th, but because it is holiday for us at Planetarium, on June 29th itself, we are organizing this lecture. So before I start, let me thank all the colleagues of mine who are here, who have been instrumental in making this a success. Organizing such a thing is not easy. I'm just speaking, standing in front of you and speaking, but so much of work has gone in. They're all there, you can see. And if you enjoy some of the visuals, see, I believe in, making it quite lively. If you go on talking about something without any visuals, it will not have any impact, in fact. You will not be able to relate yourself to such an happening. So from that point of view, I have tried my level best to collect good visuals almost in the public domain. And as far as these visuals are concerned, I thank Mr. Deepak, who is my colleague here. So all others, Ravi, Anand, Dinakar, Sharanya, all of them, they have contributed a lot in organizing this. Thanks to all of them. Now, the title, Survival at Stake, Defending the Earth from Asteroid Attack. This is the caption. It looks quite apocalyptic. Duranta, disaster anta ansate. No, that is a possibility. Let me tell you, I'm not threatening and I'm not scaring anybody. This kind of pralaya, this, that. No, I'm not doing anything like that. There is a possibility, small possibility. Whenever scientists say that, they may say that there is a chance, there is a probability it will come and hit. Media picks up and says it is going to hit. This kind of thing sometimes which comes. Not all the media. Sometimes it happens. But that is not the case. What is important here is the probability. That is what is important. And now let me start the lecture. So if because of the possibility of an asteroid coming and hitting the Earth, okay, if our survival is at stake, okay, because of that, however small it is, then how do we defend from such an asteroid attack? How are we going to defend ourselves, the entire Earth, from asteroid attack? That is what I'm going to concentrate on. Last year I spoke about the asteroidal exploration. Okay? This time it is different. I'm concentrating on another subject pertaining to asteroids. Now, let me tell you once again, I'm speaking on this subject as a science communicator, as a passionate science communicator. I'm not representing any organization, and I'm not here to scare people that something is going to happen which is apocalyptic or anything like that. No, there is a possibility. Okay, that's all. I'm emphasizing that. Now, why it's not, it is not switched on? Oh, good. Thank you. Okay, now let me go to the first slide. Can you switch off these slides, some of them? They can better, at least this part. Okay? Na kanalva. Okay. Okay, don't worry about it. Oh, for YouTube live. Otherwise, I'm visible to all these people. Okay, now look at the Earth of today. You can see Australia there, Africa, India went, Saudi Arabia, South America, North America, the Pacific. Fantastic, isn't it? This is Earth, today's Earth. Fantastic. This is Tokyo. So, see the human civilization. What is the population of the Earth today? 8 billion. Okay, 800 billion. Sorry. How much? 8 billion. That is what I want. Okay. That is 800 crores. Okay? That is, so many people are there. People are happily living on the surface of the earth today. Was it like that always? Let us go back about 66 million years back, 6.6 crore years back. Okay? Let's go back. You see, look at that. This is the way earth looked at that time. For example, you see, Africa was not like this, South America was not like this. There were a lot of differences, okay, due to whatever we say continental drift, okay, or due to plate tectonics, I say. So, this is the thing. At that time, if any alien were to come to earth, that life form, probably intelligent life form, would have decided that earth was the planet of dinosaurs. Okay? That was the dinosaurs were dominant. They were so dominant, they were terrorizing all others. Look at that. Tyrannosaurus Rex. Okay? This is the thing. Look at that. That is the way it used to terrorize. And in the so in its presence, in the presence of dinos, mammals were very small creatures. Very small creatures. They were not at all dominant. They were invisible almost. So that was the thing. And now look at that. Then something happened. See, there were rocks in space, rocks. I have not yet defined what they are. See, look at them, they are of different types. And one rock which was 10 kilometers in diameter, okay, it came and slammed the earth at, let us say, 25 kilometers per second. 25 kilometers per second means you can know, in fact, it is about more than 80,000 kilometers per hour. Okay? What dinosaurs did? They were mere onlookers. Nothing was possible for them. They could not understand anything. But they saw something, flaming rock coming up. And this rock, which was 10 kilometers in diameter, coming at more than 80,000 kilometers per hour, it came and slammed into earth at a place today. It is called as Yucatan Peninsula in Mexico, in fact. Yucatan Peninsula. And it gouged out a crater. The Yucatan Peninsula was not like this at that time. Okay? Anyway, it gouged out a crater. And because of this asteroid hit, lot of dust and rocks, they were thrown out into space, in fact. One was the crater which was there, then dust, lots of dust. We can't even imagine. It was really apocalyptic at that time. Okay, it was thrown out, rocks went up. And after some time, the thing is, entire earth was blocked. Okay, the sunlight could not enter at all. And before that, you see, lot of rocks which had been thrown into space, like missiles, they came back, in fact. And that was the end of it. 75% of almost all dinos, except non-avian dinosaurs, they say. Dinosaurs which were flying. Today's birds are the descendants of dinosaurs. The only remnants of dinosaurs today which are living with us are birds. There was a dinosaur by name Archaeopteryx. Okay, that is the thing. So, anyway, dinosaurs died, and see, one man's food is another man's poison, probably. So, whatever was there, when dinosaurs actually, they got decimated, they became extinct. Not all the life forms died. Only dinos, which were dominant, almost all the dinos and many other forms of life, they died. But mammals, somehow they survived. They were very small. This is kind of a shrew, a rat kind of thing, a mammal. And it survived. And because of no competition and terrorization from dinos, and other dominant life forms, mammals got expanded. Mammals, then primates within mammals, then ultimately human beings, in fact. So that's how, thanks to that asteroid, okay, that space rock, which, which was 10 kilometers wide, it hit the earth. Today we are living. If that were not to happen, then Earth's history would have been different, in fact, definitely. So today 8 billion of us, 800 crores. India itself is having 150 crores. Okay? Now, at that time, a rock came, and even before that, rocks had come and hit the surface of the earth. Rocks means, don't think of rock which is small. I said this rock was 10 kilometers wide. Okay, space rock, let us say. I have not yet defined what it is. Today also there is a possibility they may come and hit. I told Tunguska in 1908. Okay, may not be 10-kilometer wide one, but Tunguska thing was 100 meters wide, 330 feet. Okay, and let us see. In 2013, again in Siberia, in a place called Chelyabinsk in Russia. In Siberia also, Tunguska also, it was in Russia at that time, and in between Soviet Union came, and again Russia came back. In 2013, I'm going to show you a video of CNN video. Just you can have a look at it. You don't have audio for that? It's okay, don't worry about it. Look at that. This is the way a space rock came, and the way in which it came, look at that. It was not a big one, some 40 meters or something like that. Okay? Not even 40 meters, even smaller than that. Look at that, the way in which it went, and yeah, there was a sonic boom, and you can see how people were. This one, about 1,000 people, they were injured. Nobody got killed, at least to my knowledge. And so, that's the way it is. Look at that, the way in which glass broke. Okay? So this was in 2013. So the threat from space rocks is ever present. But how serious is that threat? It differs. Okay? That is why I'm telling. Survival at stake. Okay? So this is the thing you can see. See how people, the way in which look at that, the way in which that space rock came and hit. 2013, that's all, just 12 years back. 12 years back. Look at that, people are looking at that. So, that's the way it is. And anyway, a lot of visuals you see. Let's not worry. And about 50,000 years back, a space rock again, which is about 160 feet wide, okay, 160, 180 feet wide. It came and hit a place which is today known as Arizona, in fact, okay. It is known as Barringer crater or meteor crater. The circumference of this crater is nearly 3 kilometers. And depth is 550 meters. I myself have visited this. Oh, what a real experience it is. When I stood there in front of that, they don't allow you to go inside. They're all geologists, they are allowed. People like us, ordinary people, they're not allowed. But it is a fantastic, now you can imagine. It is known as Barringer crater or Great Crater of Arizona. Okay, so this is the thing. This was gouged out. It was created by an asteroid again. Okay, a space rock. Now, when 66 million years back, when a space rock came and hit, dinosaurs, they were helpless. Okay? Okay, they became extinct because of that. At least that is what most of the scientists agree. Then today, is it the case with human beings also? Human beings are intelligent. See, they have the wherewithal today to defend themselves, provided a lot of time is there for you to prepare, for them to prepare, as well as the detection has to be much, much earlier. So I'll tell you about this. So in 2022, humans launched a space, 2021 they launched a spacecraft, NASA launched a spacecraft. It went in about 10 months, it went and hit a space rock which was circling around another space rock called Didymos. Look at that. See, this one space rock, smaller one, is circling the other, the bigger one. The bigger one is called Didymos. The second one, smaller one, is called Dimorphos. Okay? Look at that. This spacecraft is going in 2022 September. Look at that. How this is not a video which is concocted. This is the real video taken by the spacecraft. Yes, that's all. That's it. Look at that. You can see that's all. It got smashed. So till the last moment you received the pictures, in fact. Look at that. Big one is called Didymos. The smaller one which got the hit, it was called as Dimorphos. Now, what are these space rocks? Till now I have been calling space rocks, space rocks. Okay, let us see what these space rocks are. Today we know about solar system. Let me tell you something about fundas. Because for general public, that's what I want to do. Sun is at the center of the solar system. You have 8 large bodies which are circling the sun. Okay, they are called as planets. Around most of them, except for the 2, Mercury and Venus, you have at least one other smaller body circling the planets. They are satellites, and you have like broomstick kind of appearing bodies called comets. Okay, then you have asteroids. Asteroids are mostly, this is very important, asteroids are found between the orbits of Mars and Jupiter. Okay, look at that. 8 planets are there. You have Mercury, about 6 crore kilometers from the sun, Venus 11 crore kilometers, Earth 15 crore kilometers from the sun on the average, Mars 23 crore kilometers, Jupiter 78 crore kilometers. This is 23, this is 78. There is a large gap between the two. Then this is 78, this is 145 crores, this is 285 crores, this is 485 crores. Look at that. Outer solar system, the planets are separated by large distance, but there is a wide gap between Mars and Jupiter. Okay, look at that. So between Mars and Jupiter, more than, at least as we know, more than 1.3 to 1.4 million small bodies are orbiting the sun. It is called as, collectively they are known as asteroid belt. Okay, asteroid belt. And most of these bodies, they are there in that belt. They are known as asteroids. Planets, satellites, comets, we all know what do we mean by asteroids. Why they are called as asteroids. See, look at that. As I told you, asteroids are there in the asteroid belt for the most part, but not all of them, most of them. Okay? Look at that. Some asteroids are sharing the orbit of Jupiter. Yes, it is possible. They are known as Trojan asteroids. This is known as main belt asteroids. They are Trojan asteroids. Then for us, what is important is these kind of asteroids. See, asteroids which cross the orbit of the Earth. They come near the Earth and they cross the orbit of the Earth. Such asteroids are called as near-Earth asteroids. They are dangerous, in fact, dangerous. Okay, one of them called Apollo group. Okay, because the first asteroid which was discovered was called as Apollo. That is why orbits, whichever asteroid has such an orbit, it is called as an Apollo asteroid. Okay, look at that. This is the orbit of the Earth. It is crossing the orbit of the Earth here. Crossing the orbit of the Earth there. If Earth happens to be there when it crosses, then it is danger for us. That is a possibility. Then you have another group of asteroids called Athens. Okay, look at that. Again, they are also crossing the Earth. Okay, but their orbit is not going up to asteroid belt. They sometimes they come within the orbit of the Earth and cross and go out again. Okay, they are Athens. A third group of asteroids are there. They are called as Amors. Amor, Amors. Because the first asteroid which was discovered in that orbit, it was called as an Amor asteroid. Yes, but they don't cross the orbit of the Earth. Can you see that in the picture? They are not crossing the orbit of the Earth. They are coming very near to the orbit of the Earth. But still they are near Earth asteroids, in fact. But how big are these asteroids? When asteroids were discovered in thousands, okay, many scientists thought that they are the pieces of a planet that exploded. But scientists today think that asteroids are the pieces of a would have been planet. That planet never formed between the orbits of Mars and Jupiter. No. They are still pieces only which have not come together, coalesced, and formed a planet. No, it is not possible. Look at that. This is the moon. This is the largest asteroid in the asteroid belt called Ceres. And this is Vesta. This is yet another. There are, as I told you, we know more than 1.4 million asteroids. We know. And what is the mass of these asteroids put together? It is not even 3% of the mass of the moon. Our moon is 80 times having a mass which is 80 times less than that of the Earth. 3% of that is the all asteroid masses put together. Not a very big thing. So this is the way the asteroids are there. Anyway, they are not pictures which are drawn by an artist. They are the real asteroids as they looked, and they have created an animation using. They are really asteroids. They look like this. I'll show you the pictures. So I told you 1.4 million asteroids, at least 1.3 we know, and their collective mass is only 3% that of the moon. Let me go to the history of the solar system very quickly. Okay. The thing is, Galileo was a Copernicus. We know that he created a scientific, he initiated a scientific revolution by saying that Earth, Sun is the center of the solar system or universe, whatever it is, he told at that time. Then the proof for Copernican system was provided by Galileo through observation. But all these people, by 1600s, scientists understood that planets revolve around the sun, okay, in elliptical orbits. Of course, Johannes Kepler told that Earth also revolved around the sun. But how big was the solar system? If you say this is this big, it's of no use. You have to quantify it in science. What is the distance between the sun and the Earth? People wanted to know. The average distance between the sun and Earth, it is called as 1 astronomical unit. 1 astronomical unit is the average distance between the Earth and the sun. How big is it? How big is the astronomical unit? It is 93 million miles or 150 million kilometers or 15 crore kilometers. We are more familiar with crores and lakhs here. Okay. Anyway, how did we know that? How did we measure the astronomical unit? Though when we measured it for the first time, it was not direct. Yeah, it is indirect. Okay. And the man, we have to be ever thankful to him. He is the man who indirectly calculated. He was responsible for the calculation of the astronomical unit in the sense. His name is Jean-Dominique Cassini. In fact, that's why NASA named a spacecraft which went to Saturn after him. Cassini, Jean-Dominique Cassini. He was the man who found out the difference between Earth and Mars. And from that, the third law of Kepler was used to find out the distance between all the planets, in fact, from the Earth. What a great thing, in fact. So Cassini and astronomical unit was known by 18th century. There was a person by name Johann Titius, okay? He mathematically, he started something. It is very easy for even small kids like him. Okay, you start a series 0, 3, next twice that number 6, next is what? 12, next, like that you write. Okay, add 4 to each number. 0 plus 4, 4. 3 plus 4, like that. Then go like that and divide that number by 10. 0 plus 4 is 4. 4 by 10 is 0.4. 0.7. 1. So, those numbers you take 0.4, 0.7, 1. Next comes how much, whatever it is, okay? That you think as astronomical unit, okay? That signifies the distance between the sun and each planet, he told. There was a coincidence. It was somewhat like that. So his name was Johann Titius. It was only a mathematical curiosity or a rule. Many people believed. And it was popularized by another German scholar, the German scientist, okay, an astronomer by name Johannes Bode. Johannes is nothing but John in German, okay, Johannes Bode. So, in that Titius Bode law, there was something, and it appeared to signify a planet between Mars and Jupiter. You write out that series, you will come to know about it. So is there a planet between Mars and Jupiter? Anyway, there was a very big gap. Is it true that such a thing is there? The Lord who created this universe would not have done like this. Even Kepler or somebody would have told. He told, it seems. God has created all this, means this kind of asymmetry would not have been there. There must be some planet there between Mars and Jupiter. That was the way it was. It was thought, and many people believed it. And in Italy, there is a place called Sicily. Okay, it's an island in Italy. Everybody knows Godfather takes place in Italy, in Sicily only. Okay, Mario Puzo's, this one. And there was an astronomer and a clergyman, okay, who was a priest, Christian priest, in fact. His name was Giuseppe Piazzi, okay, Giuseppe Piazzi. He, in 1801 AD, on the very first day, January 1st, he was searching the skies, and he found an object that was moving against the background of stars. Not immediately, that he found out that it was moving against the background of fixed stars. Then the thing is, he was not feeling well after some time. He left that. Again, he found it out in December. It was rediscovered. But in which orbit it was there? Where was it? Where was it moving in solar system? People scratch their heads. And this is the Palermo Observatory in Italy, in Sicily. And this Giuseppe Piazzi, he named whatever moving object, heavenly body which he had discovered, as Ceres. Okay, Ceres is the patron, the goddess of Sicily. Okay, there. So that name was given by him. Okay, and the name of a body it was. Nobody knew, but there was a brilliant astronomer. I want to start a mathematics series. That's why you should know, kids especially know. You should all concentrate towards mathematics. Without mathematics is the language of science. That is what Galileo told. Okay? And this astronomer, he is very close to my heart. Can anybody identify from his picture? His name is Carl Friedrich Gauss. Gaussian theorem in engineering and other places you will see. Carl Friedrich Gauss, what a brilliant mind he is. In fact, from whatever small observation Joseph Piazzi had of that series, he could able to estimate the orbit of that. Even today, I worked in the field of satellites, and I knew as to how my friends were. I didn't do anything, but my friends, how they were calculating the orbit of satellites. See the kind of thing. With small amount of information, he could able to fit in an orbit. And there it was. That series, that heavenly body called series, was moving between the orbits of Mars and Jupiter. Oh my goodness, have we found out that new planet between Mars and Jupiter? People had to wait. Anyway, all said and done, in 1801 New Year's Day, Joseph Piazzi found out this series, okay, this heavenly body. Within 15 months, in the same similar orbit, one more body was found, okay. That was named as Pallas, P-A-L-L-A-S, Pallas, okay. Then, in 1807, two more heavenly bodies were found in the same region. They were named as Juno and Vesta. So, series Pallas, Juno, Vesta. Four were there in the same orbit. And astronomers tried to focus their telescope towards them. And normally planets, they look like dots of light to us. But you take a small telescope and focus the telescope towards them, they expand into globes. But these things were not doing like that. Still there were dots of light. What did it mean? They were very small. So the thing is, William Herschel, who discovered the seventh planet of the solar system, Uranus, he named them asteroids. Asteroids means star-like. Even in telescope, they look star-like. That is why they came to be known as asteroids. And in the 19th century, many asteroids were found. After 1807 till 1845, no asteroid was found. In 1845, Astrea, okay, the fifth asteroid was found. By 1860, about 100 asteroids had been found between Mars and Jupiter, mostly in fact. Then by 1890, these were the 19th century telescopes which were used to discover many asteroids. And in 1891, okay, Thomas Wolfe, he invented astrophotography. Instead of observing and just calculating the position and all those things, people put a camera instead of the eye and took the pictures. So that became easier, and asteroids were 1920, okay, about 1,000 asteroids were known. By 1920, 1,000 asteroids, and by 1980, 10,000 asteroids were known through telescopes. By 2000, 10,000 asteroids were known. Okay, so that is the way it is. 100, 1,000, 10,000, and 100,000, 1 lakh. So these were the telescopes, and many of them, they are like this. Even smaller telescopes are used to find out asteroids today. Then on October 4th, 1957, Sputnik 1, the world's first artificial satellite, was launched, and humans had the ability to send something to space. But Sputnik 1 was launched on October 4th, 1957, but the first spacecraft which passed through the asteroid belt, okay, that was in 1972. Okay, so after 15 years after the dawn of the space age only, the very first spacecraft called Pioneer 10, okay, it has left the solar system. 1972, they launched it, okay, Pioneer 10. So this is the one. We think that there are 1.3 million asteroids in the asteroid belt. Means even scientists were thinking whether we will be able to pass through that asteroid belt. But nothing happened to it. After so many spacecraft have passed through it, okay, nothing has happened. Why? The average distance between two asteroids in the asteroid belt is only 1 million kilometers. The chance, what are the chances of a spacecraft hitting an asteroid? Do you know what it is? 1 in a billion. Okay, so nothing happens. See, when you see the animations there, all of them, they appear nearby, but that is not the case. Okay, so Pioneer, then asteroids were a scientific curiosity because, after all, asteroid-like bodies called planetesimals, they were responsible for the formation of the planets. So then asteroids are some kind of time capsules. They are going to tell us about the early solar system, the way in which solar system was born and the solar system evolved. People thought there is nothing wrong in it. But in 1980, there was a revolution in this regard. There was a sea change in the human perspective on asteroids. ನಾವು ಯಾವ ದೃಷ್ಟಿಕೋನದಿಂದ ಈ ಆಸ್ಟ್ರಾಯ್ಡ್ಸ್ ಅಥವಾ ಕ್ಷುದ್ರ ಗ್ರಹಗಳು ಅನ್ನೋದನ್ನು ನೋಡ್ತೀವೋ ಅದು ಬದಲಾಗೋಯ್ತು. ಯಾತಕ್ಕೆ? ವೈ ವಾಸ್ ಇಟ್? ಡು ಯು ನೋ? These two, father and son pair, both of them are Nobel Prize winners. Walter Alvarez and Louis Alvarez. They put forth a theory in 1980 that 65 million years back, dinosaurs became extinct because of an asteroid hit, they said. Now it is refined to 66 million years, not 65, because a lot of research has gone in. So, from that time onwards, oh my goodness, if that is the case, then asteroids will come and hit one day or the other. So, in addition to looking at the asteroids as though they are some kind of resources, they are tools and such things, they are viewed as some kind of a threat also. So, from that time onwards, things started. And in 1990, okay, 89, 90, around that time, Galileo spacecraft, 1990, it was launched, okay, named after Galileo Galilei. And because of his dedication to science, Galileo had to suffer a lot in his life. And paradoxically, the spacecraft named after him also suffered a lot. Okay, first of all, it was supposed to go to Jupiter directly. It could not go because Challenger space shuttle exploded and 7 people died. The first would have been teacher in space, she died. So no, Galileo kind of spacecraft with a liquid rocket engine can't go. NASA ruled. So they had to take a circuitous route. Okay, 1990 to 1995, it had to wait to go to Jupiter. So on the way, it had to cross the asteroid belt, and this is the way. Look at that antenna did not deploy at all. If it were to deploy, it would have been like this, entire thing. Now, since it did not deploy, it was like this. Anyway, Galileo did a fantastic job. This was the first. You see, I want to tell you the systematic way in which humans are exploring asteroid. But I'm not going to tell you much about it. And look at that. This is the first asteroid in the asteroid belt to be explored by a spacecraft. This is the real picture. Nobody knew how an asteroid looked. Real asteroid. Okay. This is called Gaspra. 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 Okay. It is only 18 kilometers in diameter at the most. Gaspra. This picture was taken by Galileo, and this is another asteroid called IDA, IDA. And the surprising thing was, this 60-kilometer asteroid is having a moon there, which is 1 kilometer in diameter. It is called as Dactyl. Okay, that is the one. Okay, so this is IDA, and look at that IDA, how it looks. You see, asteroids will, like Earth, asteroids are also spinning around their axis, in fact, and it will be more chaotic many times. Because, asteroids, always I say, they are like celestial potatoes. They look like potatoes only, except for Ceres. Okay? Next, look at the way in which this asteroid is called as Eros, E-R-O-S. It is named after the Greek erotic god. Okay? Americans are, they do fantastic science, but a lot of spices are put to make it interesting. There is nothing wrong in it. And Americans sent a spacecraft, wonderfully explored this asteroid called Eros. Okay? Eros. And look at the way in which it is rotating, you can see. This is not animation. Okay? Then this is the spacecraft called Near Schumacher. Okay? Near Earth Asteroid Rendezvous. That is the name of the spacecraft. First it went near this asteroid and it started circling Eros asteroid that is named after erotic god. Americans were very particular. They put it into an orbit around Eros on Valentine's Day. Okay, February 14, 2000, they put it. Name of the asteroid is Eros. Spacecraft Near, N-E-A, Near, okay. You can, if I say expand, you will get confused. Near Earth Asteroid Rendezvous. Anyway, then it slowly landed on Eros. This Eros is not a very big asteroid. Okay, it is about 30 kilometers or something like that. That is the width maximum. And in 2001, they even landed on it. Landed means it is not like human landing on the moon. They slowly put it there. It is settled there, nothing else. But they could able to land. Next, I'm sorry. Oh, yeah. Next, it was the turn of Japan. Okay. After Eros, Japan, it sent a spacecraft towards an asteroid, which is not about 500 meters wide or something like that. It is called as Itokawa. Itokawa, okay? Itokawa was the name of a rocket scientist, okay, whom Japanese respect a lot. He was responsible for the initiation of the Japanese space program. I want to mention here that Hideo Itokawa was in Trivandrum. He trained our space scientists also in the 1960s at Tumba. ISRO, at the time ISRO was not there, space scientists. So look at that. This is Hideo Itokawa, named after him, Itokawa asteroid. Look at that, another potato. Okay? So this is the orbit of the spacecraft which went and met the asteroid. See? The name of the spacecraft was Hayabusa. In fact, first time, last year also I told, when I told that name to my son, he was very young at that time. He said, "Oh, Hayabusa." I understand. How does he know about spacecraft name and all those? Such a small boy, 5th standard or something. Then I asked him what. I was not knowledgeable. Suzuki Hayabusa is the name of a motorbike, in fact. So that is peregrine falcon. That is the name of Haddu. That is the thing. So this is the way, it's not easy. You have to travel for months or years together to meet the asteroid properly. Look at that. Hayabusa 1 went and collected samples with great difficulty and brought back to Earth. Look at that. First, you pass nearby an asteroid. Then, you orbit an asteroid. You try to land on it. Next, you go there and collect samples. Okay? Hayabusa 1 has collected samples from Itokawa and it has brought here in this. And next, Japs, again, they sent one more spacecraft called Hayabusa 2, okay, to an asteroid called Ryugu, R-Y-U-G-U, Ryugu, okay. That is the name of the asteroid which they named. They only discovered it is hardly about 500 meters, 300, 400 meters wide. That's a very small asteroid. My dear friends, one thing, you can make a spacecraft to go and orbit a planet because it is spherical, the gravitational field. But what about these potatoes, in fact? They don't have a uniform gravitational field. How do you put them into orbit? No, it's very difficult. That is where humans are. You see, step by step they are progressing. This is Ryugu, and this is Hayabusa 2, and it went to Ryugu, and look at that. It started orbiting it, and again it collected samples from Ryugu. Okay, so look at that. Yeah, that's the way it is. Yeah, it collected and came back by 2020 or so. Look at that. This is the, yeah. Yes. No, the thing is, it is for collection. See, you can see that the way in which it collected, probably some compressed air kind of thing. So that, look at that. Look at that. Otherwise, how do you collect? It is like a child's pogo stick. Yeah, that is the way. Even Americans use a similar thing. Okay? So, these are the small boulders, rocks on the surface of the asteroid Ryugu. It was the turn of Americans. They sent their spacecraft called Osiris Rex, okay, to another asteroid called Bennu. It is not Kannada Bennu. It is Bennu means a mythical bird of ancient Egypt. So this is also a small 250-meter wide rock. That's all asteroid. Okay, these are all near Earth asteroids. Eros, Bennu, Ryugu, all these things. Okay, Itokawa, they are all. Okay, look at that. Osiris Rex. See, you can see, sir. This is the way. This also corrected samples. Okay, it compressed air was just blown, and whatever came up, it got collected. Okay, that is the way it is. And it was also brought back. Look at that. This is the real picture taken by the spacecraft from the surface of the asteroid. Now, look at that. This is how it looks. And there are other missions, asteroid missions, which I don't want. I'm not talking about asteroid exploration and all those things. See, what I want to tell you is, before humans could able to do anything to an asteroid, first thing is, they passed by an asteroid to see how it is. Then they went nearby, very near to the asteroid, started orbiting it, landed on it, collected samples from 3 asteroids, landing on them. Now they became more confident. So then there was a revolutionary development in this regard, and one spacecraft mission called DART. D-A-R-T. DART means, we know the way in which we throw, okay, darts. But it is double asteroid redirection test. That is the test they did. And now I want to show you, what was it? Actually, there is a near-Earth asteroid pair called Didymos and Dimorphos. I showed earlier. Didymos is a 760 meter, less than a kilometer wide asteroid, and it has got a satellite called Dimorphos, which is 180 meters wide. So Dimorphos goes around Didymos once in 12 hours roughly. So what humans wanted to test was, if a rock, space rock, an asteroid comes on a threatening course to collide with the Earth, can we deflect it? That is what they wanted to test. Through what method? Called as kinetic impact. You send a spacecraft and slam it to an asteroid. Whether it can change its path, let's not use the high sounding words like orbit, trajectory, and such things. For kids, can we change its path? That is what they wanted to test. And it was a huge success. That is what I want to show you now. DART mission, what it is. Look at that. This was a spacecraft, okay? You can see the DART spacecraft there. Yeah. Then unfolds its solar panels, big solar panels. Then, okay. Then, okay, it ejects the lens cap. Yeah. See? Didymos, bigger one, Dimorphos, smaller one. See? See, they are going like that. It's a near Earth asteroid. Okay? Though it doesn't threaten, it comes near the Earth. That's why, look at that. This was a very micro satellite. Okay? That wanted to take the pictures of going and slamming. Look at that. See? Yeah. Dimorphos. So this is DART spacecraft. Look at that. The camera itself is used for navigation. Boom. That's the end of it. It went and hit. I'll show you yet another video. Because two asteroids are there, one around the other. Sharanya, this YouTube, can you do that? Oh, okay. I think you told me, but I'm scared a little bit. It is too high tech. Okay. How it did and what happened to Dimorphos? It's not going. It's coming. Yeah, it's coming. It will come. It will come. Don't worry. Oh, it's coming here. Why it's not coming there? Oh, just a moment. Kindly bear with me. It's not coming. Just now we played, it came. I don't know, really. This is the problem. You should not face such problems while launching a spacecraft, in fact. Okay, it has come here. This is different. This will play, don't worry. Yeah, look at that. This is the one I played earlier. Yeah, this is the one. Again, I'm playing Didymos, Dimorphos. Okay. Look at that. DART spacecraft is going towards that. Yeah, it is approaching both and it is bypassing Didymos. Yes, the target is Dimorphos. See, it is taking a revenge on asteroids. So they slammed the Earth, we slam them now, in fact. Oh, boom. Yeah, that is the last frame. The camera got smashed. That is why. Till the last frame, you see. Then let me explain what happened. So, Dimorphos was going around Didymos in 12 hours. Because when the spacecraft went and slammed into it, even Americans were surprised. Its orbital period, that is, instead of 12 hours, it became 11 hours, 28 minutes. See, these two asteroids are not going to come and hit the Earth. That danger is not there. That is, probability is very less. Okay? That is why they chose like that. They don't want to take chance to some asteroid which is coming towards Earth, and instead of doing something, we should not get into problem again. So safest thing they do. So this is what is about double asteroid redirection test. This is the first attempt of humans to test whether they are capable of defending themselves. Look at that. Yeah. There it is. That is the impact. This is taken by a ground-based telescope, in fact. Okay. So that is the thing. Again, you can see. Yes, there goes the hit. Yeah, you can see the plume also, in fact, there. And now, let us see near-Earth asteroids. I told you there are about 1.3 million asteroids in the asteroid belt, for the most part, let us say. Out of that, about 30 to 40,000 of them are near-Earth asteroids. That is asteroids which come near the Earth. That is, they come within, say, 45 to 48 million kilometers of Earth's orbit. Okay? Then, among them, they are near Earth asteroids. And some of them, if They come still nearby, okay, still nearby, and let us say some 80 lakh kilometers or something like that. And they are at least 500 feet wide, means they are classified as potentially hazardous asteroids. Not only near Earth asteroids, potentially hazardous asteroids. So 30,000 to 40,000 of them are there, NES. If an asteroid comes, how are we going to defend now? Are we like dinosaurs? Definitely not. So, first step in this regard is make a survey, detect the asteroids, ascertain their orbits, find out whether they are potentially hazardous. Then you do whatever you want. So, lots and lots of telescopes all over the world, they are there. Especially Vera Rubin telescope, just 3-4 days back, it was initiated. Fantastic pictures it has taken of the galaxies and other things. And of course, these telescopes can track satellites also. This is the one in Arizona, and some telescopes in Hawaii also are participating. And there is another thing. Some spacecrafts are also participating in it. One is called as Neowise. Yeah, this is a spacecraft. So actually this is a spacecraft which was launched for, wide field survey. It was related to cosmology, nothing to do with asteroids which are so small. But once its primary mission was over, it was hibernating. Okay, they put to sleep. Again, they revived in 2013, and they used for asteroid hunting, and hundreds of near-Earth objects it has found. Now, they are going to the next step. Another satellite, I will show it later. I told you, first, make a survey, detect the asteroids, and then ascertain their orbits. It is not easy. Why do we need to know the orbit of an asteroid? Because today it is here, tomorrow where it will be, after 10 days where it will be, after 1 year where it will be. To know that, you have to ascertain the orbit. So that is the reason, ascertain the orbit, then find out, all these things with the help of computer. Today, as far as asteroid survey and asteroid detection is concerned, two things have helped a lot. One is computers. The other one is charge coupled devices, CCDs. In fact, even my mobile has got CCDs. Okay, they have revolutionized astronomy, in fact. So, after making a survey and ascertaining orbit, if a threatening rock is there, whether is it a potentially hazardous asteroid, find out. Then, spectroscopically, you can study the composition of the asteroid. See, if you want to defend yourself from an asteroid, it is not only its shape, size, density, that is not sufficient. Composition. Okay? Porosity. Whether it is a monolithic asteroid, that is a single rock, or it is a rubble pile. They behave differently. You have to be very cautious while zapping them, in fact. Okay? Look at that. First method of dealing with asteroids is kinetic impact. What DART did. That is, when you have plenty of time, you can do that. Next, this is the hit of a comet. Okay, I mean, a comet was hit by a spacecraft long back, 20 years back. Asteroid just now, DART, comet, we have hit. Okay, this is the way. And one thing is kinetic impact. Second thing is, some people, they proposed gravity tractor, they say. Gravity tractor means, what you have to do is, you have to launch a spacecraft towards an asteroid, a small asteroid within 500 meters, not kilometers. Park the spacecraft nearby strategically and continuously fire the thrusters. The spacecraft has to be in the gravity field of this asteroid, and the asteroid tugs it. The spacecraft will not go. It will also tug the asteroid, but minuscule amount. over a period of long time, you can deflect the asteroid using this safest method. It is called as gravity tractor. Okay, this is the thing, and I don't know. Yeah, look at that. This is the way. Yeah. See, ascertaining the composition of an asteroid, how it is done, okay, using spectrometers, you will see that, okay. This is the thing. And another method is attaching an ion thruster to a small asteroid, and even though minuscule thrust will be there, over a period of years or even decades, small nudging is possible. That is the thing. Then you may have a solar sail kind of thing. Solar radiation pressure itself, to a certain extent, it can push the asteroid. That's why some people like chocolate wrapping, they want to wrap with a reflecting material. So all these things may look like science fiction today, but it is possible. So that is solar sail, okay? And the final thing is, of course, blasting a nuclear weapon near the asteroid, not on it, relatively near to it, so that it gets deflected by the shock wave itself, depending on the composition of the asteroid. If everything, this kind of thing can be employed, scientists say that when asteroid is detected very late, not too much of time is there for it, or you pulverize it, that's all, using a nuclear weapon. But there is a lot of concern about nuclear weapons being launched into space. So these are all, concepts. I am not telling, I don't know how it will be done. It is only a concept I am telling. So these are all the methods which are available to us to defend ourselves. Or you use lasers, laser mirrors, okay? Somewhat like some people have called laser bees from a beehive, okay? You pulverize the asteroid in such a way, a plume comes out like a rocket exhaust, and the asteroid gets deflected. So many methods are there, and as I told you, as far as the detection of asteroid is concerned, ground-based telescopes are there, but now spacecraft are also there. I told you about NEO-WISE, one which was studying cosmology. Later it was used, this one. That is now, its work is over. In 2027, NASA is going to launch what is known as NEO Surveyor, in fact. Okay, it's a surveying spacecraft which doesn't rely on visible light, it relies on infrared light, so that even asteroids which are not visible to us in the sun's glare, they can be detected using infrared means. And this spacecraft will not be launched into an orbit around the Earth. It has to observe for asteroids 24 hours almost. That is why it will be launched into what is known as an L1 Lagrangian point. That is about 1.5 million kilometers from the Earth towards the Sun. Our Aditya L1 spacecraft is in L1 Lagrangian point today. And this is only a small animation. Yeah, this is the way NEO Surveyor is there. Okay, so that's it. And it's having a 12 feet high shroud, so that sunlight is blocked, asteroids can be seen. So these are the methods which are available for humans in the future. See, already DART has already changed the orbit of Dimorphos, but it has taken pictures of what has happened, and ground-based telescopes also have known what has happened. But exactly what has happened, in what way things have changed, what is the width of the crater, depth of the crater, composition of Dimorphos and Didymos, all these things have to be very, very carefully observed and ascertained for us to develop strategies for any real asteroid attack. So that is why European Space Agency has already launched a spacecraft called HERA, H-E-R-A, okay, HERA spacecraft. In 2028 or so, it is going to dimorphos, didymos pair again, and it will study dimorphos. And of course, asteroids are always in the news. This year, till May, one asteroid was in the news, okay, that especially in the past few years and past few months, that is Apophis, okay, an asteroid, okay. It is also a near-Earth asteroid. In 2004, when it was discovered, they said in 2029, it's going to hit the Earth. That is, chances were very high, they said, and now anyway, the risk has been reduced. But anyway, now they know this asteroid Apophis in 2029, April 13th, Friday the 13th, it is going to pass by Earth at a distance of 32,000 kilometers. Our geostationary satellites, including our INSATs, our NAVIC satellites, they are at 36,000 kilometers. So this is coming very near to Earth. At that time, European Space Agency wants to launch a spacecraft called Ramses. This is not an Egyptian god or Egyptian pharaoh's name. This is the name of the spacecraft which is going to study Apophis in 2029. Okay? Apophis, when it passes, it's a very small asteroid, in fact. It is only 1,200 feet, that is 400 meters wide. So when it goes so near the Earth, the tidal forces will distort it like anything. All these things have to be studied in terms of composition, shape, size, orbit, rotation speed, density, porosity. All these things have to be studied using Ramses spacecraft. Ramses will study Apophis as it approaches the Earth, as well as when it goes away. And Osiris Rex, I told you, Osiris Rex went to an asteroid called Bennu, I told. Once its work was over with Bennu, now they have sent it, NASA has redirected it towards Apophis. That means it will meet Apophis in 2029 after it passes the Earth. But Ramses will study in detail before and after. So it's a very exciting time, isn't it, in fact? Next few years. Okay, as newer and newer asteroids are discovered, you will have more and more thrilling phenomena, more and more thrilling events happening. And, one has to be an optimist about humans. But, at the United Nations level, everybody has to agree. There are two things at the United Nations: International Asteroid Warning Network, Space Mission Planning Advisory. Two of them are there. These two are going to advise the United Nations. If there is a near-Earth asteroid which is about 500 feet, more than 500 feet, bigger than 500 feet, and chances of it hitting the Earth is a little more than 1% also, warning will be triggered. And in fact, the US Congress mandated that by 2020, 90% of all the near-Earth asteroids, especially potentially hazardous asteroids, had to be detected, in fact. But it has not happened with Neowise Surveyor. I showed the spacecraft recently. So, I mean, in this slide, this one. With this, they are optimistic. Within a decade, they can reach the target. Okay, look at that. Okay, next, this is Hera, this is Ramses, and Osiris Apex, it is called, not Osiris Rex now, Osiris Apex, that is Apophis mission. So I'm sure next decade and all those things, and even later, there will be a lot of exciting news about asteroids, and humans will understand more about asteroids, and threat perception and the situational awareness about asteroids is going to enhance. It is going to be enhanced significantly thanks to NEO Surveyor, in fact, that spacecraft which is coming up, and Vera Rubin telescope. Let me tell you, on the occasion of this Asteroid Day this year, why I gave this topic the caption, survival at stake, is just to create awareness. It is not apocalyptic. I'm not telling tomorrow some asteroid is coming and hitting anything like that. These are the things which scientists are doing. I'm a science communicator. I'm telling you these are the things. So, asteroid hitting the earth is a possibility. How much of it is there? But sometimes, 2013 Chelyabinsk, then this one Tunguska, all these things have happened. So one has to be aware of these things. That which Tunguska and Chelyabinsk, I showed you in the beginning itself, 2013, yeah, in a place called Chelyabinsk in Siberia, a meteor which is, say, about 20 meters or so, it came and hit. So that is the thing. It is only to create awareness. Let us be aware of the asteroids, what they can do to help us understand the history of the solar system, and they can become resource in the future. And more importantly, to a certain extent, however small the possibility is, some of them, only a small portion of them, is a threat to Earth. And humans are in the process of successfully developing technologies in meeting those threats. Thank you. Thank you very much for your kind attention. And I hope I have given you a brief glimpse of what is happening pertaining to asteroidal exploration, as well as the methods that are being thought of, not employed, to a certain extent employed in the case of DART. And what are all the other methods being thought of to meet the asteroid threat, though it is very small. Okay, thank you. Thank you very much. Once again, I thank all my colleagues and all of you for attending this. And if there are any questions, I'll be very happy to answer them if I know. Okay, please.
Thank you, sir, for such an informative and exciting talk in this rapidly evolving technological era. There are so many exciting missions coming ahead, and I'm sure many youngsters will be inspired by this. So if any of you have questions, you can raise your
Yeah,
hand.
please, sir. Yeah. No,
You
no,
can
please.
ask it in the mic.
We have to start from basics only, always.
So these are very conceptual, basic questions. First is, what is the difference between an asteroid and a meteor? And the second is, you kept saying near-Earth asteroid. So what's the other type of asteroid, and what does a near-Earth asteroid mean?
Yeah. One thing is, the difference between an asteroid and a meteor is not correct. Asteroid and a meteoroid, you can say. Meteoroids are the pieces of asteroids and comets. Meteoroids, D for delta. Okay? But what is the dividing line between them? It is very, the small portions, as big as a, if the rock is as big as a house or little bit like that, around that size, it is called a meteoroid. A meteoroid, when it comes and sphere and burns up, that phenomena, that if it survives that fiery entry into the atmosphere and survives and falls like a stone, it is meteorite. So meteoroids are pieces of asteroids and comets. Then comet and asteroid. See, asteroids are basically bodies which are mostly between the orbits of Mars and Jupiter. They are made of either a mixture of metals and rock, okay, or metals, or carbon. Okay, I don't want to use high sounding term. Carbonaceous chondrites, they say. Okay, that are made up of, let's say, a confluence of rock. So that is the difference between. Some they're in the outer belt. Okay, most of the comets, they are there in very elliptical orbits. Comets, long period comet. Halley's comet or comet Halley is a short period comet. Within back again. Yeah.
How can atmosphere help the Earth to not prevent the asteroids to hit here?
Yeah, correct. If an asteroid coming and hitting the moon, let us say, it doesn't have any atmosphere, it comes and slams. If you have an atmosphere, it accelerates. Shubhanshu Shukla is coming back after some time. When his spacecraft re-enters the Earth's atmosphere, the atmosphere creates friction. Friction slows down. At least effect is reduced. Okay? Yes, sir.
Sir, apart from the composition of the asteroid,
Yeah.
and the speed of the asteroid is the threatening factor for the Earth.
Yeah. Yeah, speed of the asteroid is threatening.
Okay.
See,
If
if
it
the
is-
relative speed is less, see,
So more,
kinetic energy is half mv squared. Basic physics,
so more it is of a speed of the asteroid that is threatening than its composition.
Yes. In addition to composition, whether it is a hard rock or a rubble pile is mostly just all rubbles coming together and through gravity they are there. Hard rock is different. So it depends. In addition to composition, speed is very important. Very, very, very important. See, if a car goes and impacts somewhere, if its velocity is 20 kilometers per hour, you increase it, some amount of damage will be there. You increase it to 40 kilometers per hour. Twice means v squared, half mv squared. Damage will be not double, it will be squared. 3 times if you increase, 9 times damage. That kind of thing. Sorry. Anything else?
Space rocks and asteroids are similar kind, or
Yeah. Space rock is a term which is used for public consumption. It's an asteroid or a meteoroid. Meteoroid, ID. Yeah.
In my school, they'll tell that atmosphere helped sometimes to like smallest rocks to blast there only and not prevent to come to.
Yeah, that is the thing. Because of heat, they may explode also depending on the composition. Yes, that is true. Correct. Anything else, sir?
ಒಂದು ಇದು
ಹೇಳಿ. Oh, I'm sorry. Near Earth asteroids, there are different kinds of asteroids. One is main belt asteroid, that is between Mars and Jupiter. This belt is between 2.2 times and 3.2 times between 3.2 times the distance between Earth and Sun. Earth is at 1 astronomical unit. Asteroid belt is between 2.2 to 3.2. Okay. Trojan asteroids are in the orbit of Jupiter. Near Earth asteroids come near the orbit of the Earth. Okay. If they come very near, let us say, okay, and cross the orbit of the Earth, then okay, it is dangerous. They come very near to the orbit of the Earth. Let us say if they say come within 30 million, 48 million kilometers or 50 million kilometers of the Earth's orbit, and if their size is more than let us say 500 feet, then they are this one potentially hazardous asteroids. Actually, in order to be a potentially hazardous asteroid is a subset of near Earth asteroids. So for potentially hazardous asteroid, the distance has to be 20 times the distance between Earth and Moon, 80 lakh kilometers, and more than 500 feet. So they are much nearer, potentially hazardous. Anything else? They asked in Kannada.
ಒಂದು
ಹಾ,
ಯಾಕಾದ್ರೂ ಕನ್ನಡದಲ್ಲಿ ಕೇಳಬೇಕು ಅಂತ
ಕೇಳ್ಬೇಕು ಅಂದ್ರೆ ಕೇಳಿ ಬೇಕಾರೆ.
ಯಾವುದೇ ಹೆಸಿಟೇಷನ್ ಇಲ್ಲದೆ ಕೇಳಿ. ಸರ್ಗೆ ಕನ್ನಡನೂ ಚೆನ್ನಾಗಿ ಬರುತ್ತೆ, ಅದರಿಂದ ಕನ್ನಡದಲ್ಲಿ ಸಂಕೋಚ ಬೇಡ. ಕನ್ನಡದಲ್ಲಿ
ಕೇಳಬೇಕು ಅಂದ್ರೆ ಕೇಳಿ. ಯಾವ ಥರ ಕನ್ನಡದಲ್ಲಿ ಬೇಕಾದ್ರೆ ಕೇಳಿ, ಕಂಗ್ಲೀಷಲ್ಲಿ ಬೇಕಾದ್ರೆ ಕೇಳಿ, ಇಲ್ಲ ಆರಕ್ಷಕ ಮಹಾನಿರೀಕ್ಷಕರ ಕಚೇರಿ ಕನ್ನಡದಲ್ಲೂ ಕೇಳಿ ಬೇಕಾರೆ. ಓಕೆ. Anyway, I think
So there
over.
is just one question online. More than one person has asked, has anyone died or such kind of thing has happened because of an asteroid impact on Earth?
It's, the thing is very difficult. That has not been reported widely, in fact. And let me tell you one more thing, even for people who are to the YouTube. See, this asteroid threat is a natural hazard. So are earthquakes, so are tsunamis, so are tornadoes and cyclones. You can't do anything about tornadoes, cyclones, earthquake, tsunamis. Fortunately, you can do something about asteroid threat. That is why we have to be happy. This is what scientists point out. Okay? So, anybody getting killed, maybe some people say that people got injured from falling pieces of satellites. Asteroid, maybe here and there, but you have to take it with a pinch of salt, such kind of reports. Not very widely reported, no, not to my knowledge. Okay?
Thank you, sir, again. And I thank all the audience, people who have joined us online as well. So thank you, one and all.
Yeah.
Thanks. So
Pleasure.
please
And
have
coffee is
refreshments
outside.
before you leave.
Thank you. Please have coffee and refreshments. Once again, I thank my colleagues who have helped in this. Thank you. Thank you very much.